Hello, in this video we are going to learn the method of integration by substitution. So I've drawn up a 6-step process. We won't always need to use each of the steps, but in our first example we will be using all of them. So step 1 says identify the substitution. So sometimes you'll be told what substitution to use, but not always. In this example I'm going to make that decision for us. We know from number 3 in a little box at the top middle that the integral of 1 over x dx is log x plus c. So when we have a linear function on the denominator, it seems like a good idea to use that as our substitution. So I'm going to suggest that u equals 3x minus 5. So that was step 1, to identify the substitution. U equals 3x minus 5. Now when it comes to actually doing the substituting, we can replace the denominator therefore with a u. But we also have this dx, and we need to get rid or substitute every occurrence of x, including the dx. So step 2 says to find du by dx, which, because 3x minus 5 is just a linear function, gives us the number 3, from which dx is 1/3 of du. And that means we can now substitute for 3x minus 5 and for dx in our integral. And that is what step 3 tells us to do. Substitute u and du by dx into the integral. So we're replacing the 3x minus 5 with a u, and we're replacing the dx with 1/3 of du. Now 12 over u times 1/3 du isn't very tidy, so step 4 says, if it's necessary, to tidy up. 1/3 of 12 is 4, and whenever we're multiplying by a constant, we can actually stick that in front of the integral sign, which makes the integral itself slightly simpler. So that gives us 4 times the integral of 1 over u du. And now it looks very much like what it says in number 3, but with the letter u rather than the letter x. So if the integral of 1 over x dx is log x, then the integral of 1 over u with respect to u is log u. So we get 4 ln u. But we have to do step 6 before we finished, because if the question is posed in terms of x, then we would want our answer in terms of x. We know that u equals 3x minus 5, so that gives us 4 ln 3x minus 5 in the modular signs plus c. Now we've been asked to use the substitution u equals x plus 2 to find the integral of 5 over x plus 2 dx. So we don't need to identify the substitution, that's been done for us. We need to find du by dx, so differentiating u equals x plus 2 with respect to x just gives us 1, from which dx is equal to du. So we can then substitute u and du by dx into the integral. Okay, so that gives us 5 over u rather than 5 over x plus 2 du instead of dx. We don't need to tidy it up, but we could write 5 integral 1 over u, but we don't need to. Then when we integrate it, we get 5 ln u, and then substituting back, we get 5 ln x plus 2 plus c. Another example, this time we're asked to use the substitution u equals x minus 3 to find the integral of 2 over x minus 3 squared. So again, we've got a substitution. Du by dx is still equal to 1. So dx again is equal to du. So when we substitute in, we're substituting u equals x minus 3, so we get 2 over u squared, and dx is du again. We can rewrite 2 over u squared as 2u to the minus 2, and if we want to, we can put the 2 out the front. So we've tidied up, or at least written it in a form we can integrate. So then we do our integration, which requires us to add 1 to the index and divide by that new index. So minus 2 becomes minus 1, and we divide by minus 1. Hence we get minus 2u to the minus 1. And then finally we substitute back. So essentially we've got minus 2 over u, which becomes minus 2 over x minus 3 plus c. Now don't ask me why, but I decided to demonstrate the integration by substitution method as a conversation between these two people here. Apologies in advance. I want to integrate 2x plus 5 to the power of 9, but I can't. Why not substitute u equals 2x plus 5 and do the integral of u to the 9 dx instead? Well, that's an interesting idea, but I can't integrate a function of u with respect to x. Well, good point. Why not substitute for dx as well? If u equals 2x plus 5, then du by dx equals 2, and therefore dx equals half of du. Makes sense. So now I have the integral of u to the 9 times a half du. Yes, which you could write as half integral u to the 9 du, because half is a constant. Then that will be a half times a tenth of u to the 10, or 1/20th of u to the 10. Right, and since u equals 2x plus 5, the final answer is 1/20th of 2x plus 5 to the power of 10 plus c. Can I do that with other functions like the integral of 26 over 13x plus 2 dx? Oops, let u equal 13x plus 2. Okay, so I get the integral of 26 over u dx. Yes, but remember I told you to substitute for dx as well. Yes, you did. If u equals 13x plus 2, then du by dx equals 13, and dx equals 1/13th du, so you get the integral of 26 over u times 1/13th du, which could simplify to 2 times the integral of 1 over u du. Absolutely. And the integral of 1 over u with respect to u is ln u. Spot on. So you'll have 2 ln u, which is 2 ln 13x plus 2 in a modular sine plus c. Certainly is. Could we give me a harder question? Sure can. What about the integral of cos x sine cubed dx? What could u be used for there? Well, it's magic. Let's put u equals sine x. So we have the integral of cos x u cubed dx. How does that help? Just watch. Don't forget we always have to substitute for dx as well. Well, if u equals sine x, then du by dx equals cos x, and dx equals du by cos x? Yes. And putting it all together, we have the integral of cos x u cubed du over cos x. That's not very simple. Haven't you noticed? The cos x terms cancel. Oh, so we get the integral of u cubed du. In other words, a quarter u to the 4, which becomes a quarter sine to the 4x. Don't forget the plus c. Did somebody say plus c? Give me more. Sure. How about the integral of x squared e to the 2x cubed dx? Well, I could integrate e to the u with respect to u, so maybe I'll try u equals 2x cubed. Good choice. And if u equals 2x cubed, what is du by dx? If u equals 2x cubed, then du by dx is a 6x squared. And making dx the subject, dx equals du over 6x squared. You got it. So now we have the integral of x squared e to the u times du over 6x squared. The x squared terms cancel out. Good spot. That gives us 1/6 of the integral of e to the u du, which is just e to the u again. Nearly. It's a 1/6 of e to the u. Oh yes, and then the final answer is 1/6 of e to the 2x cubed plus c. You are getting the hang of this. Give me one more, but make it really difficult. If you insist, how about the integral of tan x dx? Well, surely I can't just put u equals tan x. I am stumped. Okay, let's write tan x equals sine x over cos x. So that's the integral of sine x over cos x dx. Now I have too much choice. A little tip that works 90% of the time. Substitute for the denominator. Well, like u equals cos x. Exactly like u equals cos x. So u equals cos x, and du by dx equals minus sine x, and dx equals minus du over sine x. All of that. Hence the integral of sine x over cos x dx is now the integral of sine x over u times minus du over sine x, which is just a minus the integral of 1 over u du, which is minus ln u. Or minus ln cos x. Perfect. However, in the formula book it says the integral of tan x dx is ln sec x. So if I write it as minus 1 ln cos x and then use that log rule, I get ln of cos x to minus 1, and the reciprocal of cos x is sec x. As I said, sorry about that. So we're going to do a few more examples just to finish off. Firstly, use the substitution u equals 3 plus 2x squared to find the integral of x over the square root of 3 plus 2x squared dx. So if our substitution is u equals 3 plus 2x squared, then du by dx is 4x, and making dx the subject, we get du over 4x. So then substituting in, we still have the x on top, we have u to the half on the denominator, and then dx is du over 4x. The x's cancel out. We can bring the 4 out the front as a quarter, so we've got a quarter of the integral of u to the minus half du. The integral of u to the minus half du is 2u to the half when you add 1 to the index and divide by it. A quarter of 2 is a half, so the answer is a half of the square root of 3 plus 2x squared plus c. Here we have a trigonometric example. We've been asked to integrate cos cubed x dx, but we've been told to use the substitution u equals sine x. So we know our substitution, but du by dx is cos x, from which dx is du over cos x. And then we can substitute in. So we've got the integral of cos cubed x. We could just times that by dx for the time being. That's du over cos x. So we can cancel a cos x top and bottom to give us the integral of cos squared x du. But we've still got x's in there. But we know that cos squared x is the same as 1 minus sine squared x. So if we substitute 1 minus sine squared x, we can then replace the sine x with a u. So we've now got the integral of 1 minus u squared du. The integral of 1 minus u squared is u minus a third of u cubed. And then replacing the u's with sine x's give us a final answer of sine x minus a third sine cubed x plus c. In our examples so far, we've either got a number when we've differentiated, or we've had something that's cancelled out completely, and that won't happen in this example. So we've got to do the integral of 3x over x plus 7 dx. As we've seen now at least twice, we're going to substitute for the denominator. U equals x plus 7, du by dx is equal to 1, so we can substitute du for dx. So when we substitute for the x plus 7 and the dx, we get the integral of 3x over u du. But we have still got an x there, and we can't integrate that unless we get rid of all the x's. However, if u equals x plus 7, that means that x equals u minus 7. So we can just substitute for the x as u minus 7, and then everything's in terms of u. So 3 bracket u minus 7 over u. If we multiply out the brackets and then turn it into two fractions, each with a u in the denominator, that gives us 3u over u, which of course is equal to 3 minus 21 over u. So we've got to integrate 3 minus 21 over u du. The integral of 3 is 3u. The integral of minus 21 over u is minus 21 ln u. And then if we substitute back in with our u equals x plus 7, we get 3 brackets x plus 7 minus 21 log x plus 7 plus c. But just note, sometimes if you're doing a question, it might ask you to show that it is the thing at the bottom. Or if you're looking up in the textbook, the answer in the textbook might be the thing at the bottom. And you might be wondering where the 3 times 7 from the brackets has gone. But as that is a constant, that can be soaked up into the c. So we can have a final answer of 3x minus 21 log x plus 7 plus c. Similar example to the previous one. We have the integral of e to the 4x over e to the x plus 2 dx. Again, if we let u equal e to the x plus 2, then du by dx is e to the x, and dx is du over e to the x. So substituting in for u and dx, we get the integral of e to the 4x over u times du over e to the x. E to the x divided by e to the x is e to the 3x, because we subtract the indices. So we've got the integral of e to the 3x over u du. Now, we do know that e to the x is going to be u minus 2 if we rearrange our substitution. And e to the 3x therefore is the cube of u minus 2, which you could use the binomial expansion if you wished. U minus 2 cubed is u cubed minus 6u squared plus 12u minus 8. So that is our numerator. It's all over u, and we're integrating it with respect to u. So we can't integrate it as it is, but we can split it up into 4 separate terms, each having divided the numerator by u. So u cubed over u is u squared. 6u squared over u is 6u, 12u over u is just 12, and minus 8 over u is itself minus 8 over u. Integrating each of those gives us a third u cubed minus 3u squared plus 12u minus 8 ln u, and then we can place each of the u's with e to the x plus 2. So that's what I've done. I haven't got rid of any constants because it was too much hassle. Partial fractions is often treated separately, but it is just an example of integration by substitution once you've done your partial fractions. So here we've got the integral of x minus 8 over x squared minus 2x dx. So the first thing we want to do is to write them as partial fractions. So that means factorising the denominator as x minus 2, and that means our fractions are going to be a over x and b over x minus 2. Multiplying through by x minus 2 gives us x minus 8 on the left equal to a times x minus 2 plus bx. If we let x equals 2, then our a term will vanish and we'll get negative 6 equals 2b, hence b equals negative 3. And similarly, if we go back to our expression x minus 8 equals and use x is 0, that gives us negative 8 equals negative 2a, from which a equals 4. So our fractions are 4 over x, take away 3 over x minus 2, and then I've just written out the answer, but in theory you can use integration by substitution for the second term. The answer is 4 log x minus 3 log x minus 2 plus c. That's using u equals x minus 2 as the substitution for the second term. And one final example of substitution, although it looks completely different to all the others. Use the substitution u equals 2 cos theta to evaluate the integral of 1 over the square root of 4 minus u squared du. Now we start in the same way. We want to replace these u's with thetas, so we do du by d theta, which is going to be negative 2 sine theta, and hence du is negative 2 sine theta d theta. So then when we substitute in for u and for du, we get the integral of 1 over the square root of 4 minus the square of 2 cos theta, multiplied by negative 2 sine theta d theta. So for the next line, I've just included the minus 2 sine theta d theta in the rest of the fraction. So I've got the minus 2 at the front, I've got a sine theta on top, and at the bottom I've expanded the 2 cos theta squared, so we've got the square root of 4 minus 4 cos squared theta d theta. Now over on the left, rather than do it inside the square root, I'm just showing you that 4 minus 4 cos squared theta is the same as 4 sine squared theta. If you factorize out the 4 and use the identity, sine squared plus cos squared is 1. And then if we square root 4 sine squared theta, we get 2 sine theta. So we've got minus 2 times the integral of sine theta over 2 sine theta d theta, which the sine thetas cancel out and leave us with minus the integral of 1 d theta, which is just minus theta. And since u equals 2 cos theta, that means that theta is the arc cos of u over 2. So the final answer is negative arc cos u over 2 plus c. Thank you very much.